Hello everyone, we are a group of 3 students, Samah Jouini, Sirine Ayachi, and Sarra Messaoudi. In this video we are going to present for you the forecasting of a very special place that you all know. We think about it a lot during the last morning session, and when the bell rings, most of you hurry in its direction to arrive first in line. I think you already guessed what it is. Yes, that's right, it's our university restaurant. We all know how important forecasting is to all companies. It is an essential step in order to make successful decisions. In fact, in order to decide the quantity of meals to prepare each day, the university restaurant uses the short-range forecast. And to evaluate the yearly budget needed, it uses the medium-range forecast. Well, we chose to make our study on the meals prepared, and during our research, we noticed that the restaurant doesn't use any of the forecasting method we studied. They just make 400 plates every day, knowing that the average number of students that have lunch there is 335, with 45 workers and 20 professors. Well, since their method is not efficient, especially this year, most of the time we found shortage in one element of the meal, we are going to implement what we learned in the forecasting course in order to find a better solution for this problem.
So here is our Excel file. The first column represents the date since we have time series data and we will consider only November 2017. The second column represents the item to be forecasted, which is in our case meant to be the daily overall number of demanded meals. As for the forecasted models, we have smoothing models including moving average, single exponential smoothing, and double exponential smoothing, and decomposition models including additive and multiplicative models. To simplify, we will discuss only 4 techniques: naive method, moving average, weighted moving average, and simple exponential smoothing. Starting with the naive method, which states that all forecasts are said to be the value of the last observation, so that the first forecast will be simply 327. The second one will be 415, and so on. The second technique, called moving average, states that each forecast is the average demand in previous n periods. In our example, each forecast will be the average demand during the past 3 days, so that the first forecast equals to the average of these 3 values. And so forth. The third technique is weighted moving average. As for weights, we have 3, 2, and 1, where each forecast will be calculated by multiplying the given demand by its associated weighting, then summing the values and dividing by the total weights. In that manner, the first forecast will be calculated as follows: 3 times 289 plus 2 times 415 plus 1 times 327 over 3 plus 2 plus 1 equals to 6. And so on. The last technique is the single or simple exponential smoothing with alpha equals to 0.6. which means that 0.6 weight is given to the most recent observation and 0.4 weight is given to the last forecast. Here we cannot directly forecast the first value because we need the previous one. So we assume that the first forecast is simply 327 using the naive method. That way we can predict the remaining values as follows: 0.6 times 415 plus 0.4 times 327, and so forth. Once our forecasts are done, we move to the next step, the measures of forecast error. We have many measurements of forecast error, such as forecast bias, mean absolute deviation, mean squared error, and the standard deviation. For the purpose of simplification, we will consider only these three measures. The mean absolute deviation equals to the absolute value of the actual demand minus the forecast. The mean squared error equals to the squared MAD. The mean absolute percent error equals to the percentage of demand over the actual demand. Finally, we have to compute the average error for each measurement. We're doing the same calculations for the second technique, the third, and the last one. We now have to compare these values in order to know what is the best technique. Keeping error to a minimum, the results of the forecasting are that moving average is better choice.
Dear colleagues, now let's see the forecasting of budget using trend-adjusted method. We have the following data. The trend for the first year equal to 3, alpha equal to 0.2, beta equal to 0.1. Also, we have the actual budget that ranges between 352 million and 400 million. These are the formula to find the forecast, the trend, and when we add them, we find the forecast including trend. Let's just do the example for the year 2013. We have the forecast equal to alpha multiplied by the actual demand for the last period, plus 1 minus alpha multiplied by the forecast including trend of the last period. The trend for the year 2013 is equal to beta multiplied by the forecast of the same period minus the forecast of the last period, plus 1 minus beta multiplied by the trend of the previous period. And that's how we find 2.94. The same calculation goes for the other years. Now, about the seasonality index. It is an index that highlights the differences, the huge differences between seasons. Actually, in TBS, we can say that we have 4 imported seasons: exams, the job fair day, and the welcome day, and the other days. You can witness that the exams period has the lowest demand. Now, let's do all these calculations. We have the average for the year 2014. We just add the sum of all of these and we divide them by 4. The same goes for the year 2015 and 2016. For the overall average, it is the sum of all of these data divided by 12. Now, to multiply the seasonal average, we just take the average for each season, which means for the exam season, for example, it is the average of 150, 170, 190, which gives us 170. The same goes for the all other seasons. Now, we need to find the seasonal index, because if the overall average is much larger than the seasonal average, then we need to adjust the demand. So we just apply the formula, which is, for example, for the season exams equal to the seasonal average 170, and we divide it by the overall average 327.75. It gives us 0.51. The same goes for all of the other seasons. Now, to find the forecast for the year 2017, we can actually do 2-year moving forecast. It means using the average for these 2 years, or accept 500% growth from the previous year, for example. Let's just do the 2-year moving forecast. So we have the average of 315 and 334.34.
it gives us 324.67. Now let's calculate the forecast simply by multiplying the seasonal index for each season by the average demand for the year 2017. So what we find that what we are expecting is 168 demand for the season exams, 320 for the job fair, 43.9 for the welcome day, and 371 for the other days. Thank you.
So, to conclude, as decision makers, we opt for the most effective solution that will decrease the number of errors the university restaurant used to make, which is the moving average. It is true that this method and the weighted moving average gave us almost the same results, but the moving average one is easier to implement. So, dear TBSers, those who still did not get their restaurant subscription, please hurry up and do it. As you saw, it is very important to have the correct data in order to make a better forecast. Entering the restaurant without being registered, and especially when you double the amount of food, you can mislead the forecast made. As for the chef, he should follow the recommendations and the quantities given by the responsibles in order to make the exact quantity of meals demanded. Hope you enjoyed watching the video. Thank you so much.